Good morning. Today we're going to be talking about graphing exponential functions. So a little blast from the past from our IM3 days. There are two types of exponential functions. The first one that we're going to see is called exponential growth function. All right, for a growth function, the equation is given as f of x equals a to the x power. You see that x is up as an exponent. But in this case, when it is growth, the a is greater than 1, aka a whole number. And remember that a value is called the base. All right, so the base is greater than 1. So when we have the base greater than 1, our graph has a horizontal asymptote at 0. So we have a horizontal asymptote at 0, or y equals 0. It has a y-intercept. And growth, it is growing from left to right. So really close to the asymptote and then grows up really fast. And I can make that better. So really close to the asymptote and then grows exponentially fast. Now it keeps going to the left, keeps going to the right forever, and crosses through the indicated y-intercept. Now the other type, if we have exponential growth, we also have exponential decay. So again, it's given by a to the power of x, but this time a is going to be between 1 and 0, meaning that a is usually a fraction. All right, so if we have a number base that is between 0 and 1, we're still going to have that horizontal asymptote of y equals 0. So I'll just write HA, horizontal asymptote, y equals 0. Again, it's going to cross the y-axis at the y-intercept, but this time it's a decay function. So instead of going from low to high, it's going to go from high to low. So it's really up here, and then it's going to get really, really close. Continue off to the right, continue off to the left, but it's decaying. All right. So let's talk about actually graphing these. So our first example, we want to go ahead and graph the following. F of x equals 2 to the x power. So make sure you're writing that correctly. It's not 2x, it's 2 to the power of x. So usually when we don't know how to graph something the first time around, making yourself an XY chart, pretty good idea. So let's take a bunch of x values, plug them in, get y values, or in our case, f of x values. Okay. So we usually want to use the same numbers, so let's go ahead and go from -3 to +3, using -3, -2, 0, 2, and 3. We can go ahead and skip 1 because that's all right. All right, so we plug all these numbers in. So first one, we take 2, and instead of x, we're going to put -3, so that's 2 to the power of -3. All right. Now, if you remember, negative exponents means drop that entire term to the bottom of a fraction, so it's actually 1 over 2 to the 3rd power, making that 3 positive now. And 2 to the 3rd power is 8, so 1/8. And we keep working our way down this chart, so 2 to the -2 power. So that's 1 over 2 to the -2, or 1 over 4. I'll alternate colors here. 2 to the 0 power. Anything to the 0 power is 1. 2 to the 2 power, that's 2 squared, that's just 4. And finally, 2 to the 3rd power, 2 times 2 times 2, 8. So if we look at these numbers, we got 1/8, 1/4, 1, 4, 8. These numbers are getting bigger. So as we're going from left to right, the numbers are getting bigger. So we notice we're going left to right, getting bigger. This is going to be a growth function, or we could have told from earlier, our a value, our base, is 2, and that's greater than 0, or sorry, I apologize, greater than 1. Greater than 1 means it's going to be growth. So let's go ahead and graph these based on the points we have. 1, 2, 3, 1, 2, 3, and then we got to go up. Ooh, we got to get up to 8. I'm going to run out of room. 1, 2, 3, 4, 5, 6, 7, 8. So the x and y axes are on different scales, but we're going to be all right here. Okay, my first point is negative 3, 1/8. So negative 3, 1/8, so right above this y-axis. Next one is negative 2, 1, 4, so a little bit higher. 0, 1, 2, 4, and then 3, 8. All right. So if we were to continue plugging points in, say like negative 4, negative 5, negative 6, these numbers will get closer and closer to 0, but it'll never get there. So we see we're approaching our asymptote here. So our asymptote is y equals 0. So we're getting closer and closer to our horizontal asymptote. Y equals 0, but we're never going to cross it. And then going off to the right, the bigger numbers we plug in, the faster this is going to grow. So if we connect this whole thing, it'll continue off to the left, and then growing real fast, growing exponentially. So we want to put some arrows on this, continuing forever. So there's our exponential growth. All right. Let's see an example of decay. So for example, let's go ahead and graph f of x equals 1/2 to the power of x. So we can see our base this time is 1/2, and 1/2 is between 0 and 1. So this means it is going to be a decay function. But again, let's take this and put it into our next nice XY chart. So I'm going to use the same numbers as before. Negative 3, negative 2, 0, 2, and 3. Giving me a little bit more space this time. So we've got 1/2 to the power of negative 3. 1/2 to the power of negative 2. 1/2 to the power of 0. Oops. 1/2 to the power of 2, and 1/2 to the power of 3. Okay. So we start plugging these in. Remember, negative exponents, everything gets flipped. This is really 3 to the positive third. So that's a 27. Again, this one gets flipped. Fraction flips to a 2. 2 becomes, whoa. What am I doing here? I apologize. Should be using 2. 2 to the third power. 2 to the third power, that's an 8. 2 to the second power, that's a 4. Okay. Anything to the 0 power is 1. 1/2. So remember, we can apply that to top and bottom. So 1 squared is 1. 2 squared is 4. And down here, 1/8. So this time we're actually seeing numbers that are opposite last time. Now we're starting at 8, working our way down to 1/8. So we're starting from high to low, high to low. So actually, complete opposite of last time. 2, 3. Gonna need 8 marks again. Okay. So if we just real quickly put these on, negative 3, 8 goes back here and then up 8. Negative 2, 4, 1, 2, 3, 4, 0, 1, 1 fourth, 1 eighth, and as it continues, it gets closer and closer to 0, which is the horizontal asymptote. Alright, so I'll write the horizontal asymptote on here. My horizontal asymptote is y equals 0. And my decay graph is getting closer and closer to that. Up high, low, and gets closer and closer to the asymptote. Alright. A couple of notes to make here now. So we've seen the basic ones. Now, if there are some properties we can write down, so properties. So the first one is that the domain is always going to be all real numbers, no matter whether it's growth or decay. It's going to be all real numbers, so that fancy R, or we can write it as negative infinity to positive infinity. Okay, so domain, all real numbers, either way you want to write it. The second thing is talking about the range. Now the range measures up and down, depending on what the asymptote is. All right, so for the graphs that we've seen so far, the horizontal asymptote is or has been 0. So the lowest it's gone down to would be 0, and it went up to positive infinity. Or if you want to write it out, y, it's everything above 0. Now, later on, we're going to see where the asymptote changes. So in this case, the asymptote was 0. But in the future, this will depend on the asymptote. So now we're about to see a bunch of shifting. Okay, so not every time will it be a y equals 0 horizontal asymptote. So we're going to see some shifts here. Shifting. So our generic exponential is f of x equals. So what happens if we throw a number in front? We keep the base of a, negative x plus k. Alright, so I want to make a couple notes on things. So a is still our base. K, this number over here. In the previous ones, we didn't have a number. It was a plus 0, so it didn't show up. That plus 0 represents the horizontal asymptote, or the vertical shift. Whatever this number is, if it's positive 10, it's going to shift it up 10. If it's negative 5, it's going to shift it down 5. So this K number just indicates the vertical shift of the entire graph, or better known as the horizontal asymptote. Okay, whatever that number is. So positive up, negative down. Now where it starts to get a little bit tricky, see this negative sign here? If there is a negative sign there, that means there's going to be a reflection of the entire graph. So the entire graph is going to reflect horizontally. Okay, so the whole graph is going to flip horizontally. Now, if there's a negative sign in front of this value, okay, so if there's a negative sign in front of this value, that means it's going to be a reflection vertically. Okay, so this one's kind of over the, whoops. So reflection horizontally means it's going to get reflected over the x-axis. No, I take that back. Reflection horizontally is over the y-axis. Reflection vertically is over the x-axis. And then that number in there itself, that number is just a multiplier to the y values. Okay, so let's actually see one example of that, or maybe a couple, we'll see. So, an example. Let's go ahead and graph f of x equals 2 to the negative x minus 3. Okay, so just identifying a few things. The a value is 2. That's greater than 1. So it's telling me it should be a growth. Okay, so it should be a growth like this. But as we work our way through it, that negative sign tells me that this whole graph is going to be reflected horizontally. So we're going to reflect it, can't really show it this way. Okay, so instead of being a growth, it's actually going to reflect over, and it's going to be a decay in the end. And we keep working our way through, that negative 3 is the k value. And that tells me a shift, okay, vertical shift. Negative means down, so this is going to be a shift down 3. Now that's all good. We could use that information to kind of graph it ourselves. Again, we can make the XY table to help ourselves out. So we're going to do the table this time. So if you want to just ignore all the shifting, you can just plug numbers in. So negative 3, negative 2, 0, 2, and 3. So plugging in negative 3. So we get 2 to the power of negative 3. You see how those negatives play with each other? The next one's going to be 2 to the negative 2 minus 3. 2 to the negative 0 minus 3. 2 to the negative 2 minus 3. And 2 to the negative 3 minus 3. All right. So I'll highlight it. The numbers that we plugged in are in the parentheses. So either using your calculator or mathing this out. Negative 3 is positive. 2 to the positive 3 is 8. And then 8 minus 3 is 5. All right, over here. Negative 2 is 4. 4 minus 3 is 1. And then we go ahead and work our way down. Anything to the 0 power is 2. Or sorry, anything to 0 power is 1. 1 minus 3 is negative 2. All right. Might need a little bit of calculator work here. 2 to the negative 2 power. So that's going to be 1 to the 2 squared minus 3, or let's see, 1/4 minus 3, negative 2.75, and then finally 1 to the 2/3, or 1 over 2 to the 3rd minus 3, so that's 1/8 minus 3. Okay. See how that number is getting closer and closer to, looks like it's going to be negative 3. We're starting at 5. Goes to 1, to negative 2, negative 275, negative 2875. This number is getting closer and closer to 3. Sorry, negative 3, which again should be our shifted downwards horizontal asymptote. So if we were to throw this whole thing on the graph, and I'm going to try and fit it in right here. So we're going to need 1, 2, 3, 4, 5 up, 1, 2, 3 down, 3 over, and 3 over. Okay? So just a quick graph here. My first point is negative 3, 5. So negative 3, up 5. Next one's negative 2, up 1. 0, negative 2, 2, negative 275, and 3, negative 2875. All right, connecting all these. So we have up. I'm going to actually change the color so I don't mess with that other one. So it will continue off to the right, continues up to the left, and let's take a look at some things. We said that it should have a downward shifting horizontal asymptote down 3, so at negative 3. Look, that is the number that is approaching. Okay, that is the horizontal asymptote. And look at this, we said that it should be going this direction, and that's what we got. All right.